Alright, let's take a look at what we get here. Hopefully 1 and 2 are not too bad. Those should be just a little review of what we've done before. Alright, we add 1 to the exponent, and then divide by the new exponent or multiply by its reciprocal. And yes, need to remember the plus c part. For number 2, we can rewrite 1 over x cubed as x to the negative third and do the same thing. We're adding 1 to the exponent, so we get x to the negative second, and then we divide by that new exponent or multiply by its reciprocal, and remember the plus c. For number 3, if we try the same thing, 1 over x is the same as x to the negative first. We try that same method. We add 1 to the exponent. That gives us x to the 0. And then we multiply by the reciprocal. We can't multiply by that reciprocal, right? Because we get 1 over 0. That's undefined. So it doesn't work for this problem. We haven't had that before, or I've made sure you haven't had that integral in the past, because this is a special case that we're going to talk about today. And that kind of leads us in a little bit to the definition of the natural log. You've been exposed to the natural log for a couple of years now, probably advanced algebra and pre-calc. You were just told this is log base e, and that's kind of it. But really, natural log is defined as the definite integral from 1 to x of 1 over t dt. So obviously your teachers didn't tell you that because you had no idea what that definite integral meant. But we know now that this means natural log of x is going to be the area under this curve, right, the curve 1 over t, from 1 to x. So the area under this curve from 1 to x gives us the natural log. That's where it comes from. So let's take a look at a graph. Right there. Now you don't have so many numbers. Alright, so 1 over x, we're going to look at that graph. And this is it right here. Right? It shouldn't be a big surprise. That's a function we've seen before. I'm going to go ahead and change the window a little bit. And I'm going to go from 0 to 10 and 0 to 10 for each of those. So here's the graph we're looking at. And I forgot to say this is as long as x is greater than 0. Remember, we can't take a natural log of a negative number or natural log of 0. So basically, we're looking at the area under the curve. So our first example, number 4, on the paper, asks us to figure out what's the natural log of 2. Well, that would mean we're finding the area under the curve from 1 to 2. So this little piece of area is representative of natural log of 2. Let's look at what happens. We take natural log of 2, we get 0.693 approximately. If we do the definite integral from 1 to 2 of 1 over t dt, let's try that, math 9, and we're going from 1 to 2 of 1 divided by x dx. All right, we get the same thing. So I'm not a liar. That does actually equal what I said it did. All right, so those are equal to each other. We get approximately 0.693. Now, what do you expect? What kind of an answer do you expect for natural log of 1/3? If we go back to that graph, we're finding the area under the curve from 1 to 1/3. What kind of answer should we get? Negative, right? Because it's going backwards. We have the 1 to 1/3. It's kind of backwards, big number to small number. So we should get a negative answer. So let's try a natural log of 1/3. And we do get negative 1.099 approximately. And we can do that check again if we do math 9 from 1 up to 1/3. And we're doing 1 divided by x dx. We get the same thing, negative 1.099. And this last one, number 6, what's the natural log of E? It's just 1, right? This is log base E of E. E to what power gives us E? E to the first power. So that's 1. So the area under the curve from 1 to E is actually 1. We don't have to put that in our calculator to test it.